next topic is Maxwell's equations of electromagnetism. There are four equations of Maxwell. The first equation, we will study first the first equation, Maxwell's first equation. It is based on the Gauss law for electric field. What is the Gauss law of electric field? The Gauss law states that the total electric flux passing through a closed surface S is equal to 1 by epsilon 0 times the total charge enclosed in the surface. You can see the equation phi E. Phi is the electric flux is equal to integration over the closed surface S E dot dA. E vector dot dA vector is equal to Q upon epsilon 0, where Q is the total charge enclosed in the closed surface and epsilon 0 is the dielectric constant for the vacuum. For any medium, it will be phi E is equals to the integration over the closed surface S E vector dot dA vector is equals to Q upon epsilon, where epsilon is the dielectric constant for the medium and Q is the total charge enclosed in the closed surface. E dot dA, it is the dot product between the electric field vector and the area. If charge is distributed continuously inside the closed surface and rho is the charge volume density, then Q will be equal to integration over the volume rho dV, where rho is the charge volume density. Charge volume density is described as total charge enclosed in the volume divided by the volume element. From equation number 1 and 2, we can see that integration over the closed surface E dot dA is equals to 1 upon epsilon integration over volume dV, integration over volume V rho dV. It is equation number 4. This is the integral form of Maxwell's first equation. You can see that the value of charge Q is put in the equation number 2, where Q is equals to integration of V rho dV. So this is the integral form of Maxwell's first equation. The Maxwell's equations are a very important topic. Now we will apply the Gauss divergence theorem. The Gauss divergence theorem basically relates the surface integral to the volume integral. How does it relate? You can see the integration over the closed surface as E dot dA, E vector dot dA vector is equals to divergence of E dV. This is your equation number 5. From equation number 4 and 5, if we compare equation number 4 and 5, we can see that integration over the volume V, divergence of E dV is equals to 1 upon epsilon integration over the volume V rho dV. It will be divergence of E is equals to rho upon epsilon, where epsilon is the dielectric constant for the medium. Equation number 6 is the differential form of Maxwell's equation. Maxwell's first equation, it is a very important equation. If medium is homogeneous and isotropic, then it will be replaced by divergence. It will be replaced by divergence dot epsilon E is equals to rho, where epsilon E will be equal to D, where D vector is the displacement vector. D vector is the displacement vector. It is defined as D vector is equals to epsilon E vector. D vector is equals to epsilon E vector. It will be divergence of D is equals to rho. It is again the Maxwell's first equation. It is in the terms of displacement vector. You have to remember this equation. Divergence of E is equals to rho upon epsilon. Divergence of D is equals to